welcome. Thanks for joining me today. I hear you have some exciting news to talk about.
Hey, Jim. Thanks for taking the time to talk to us today. My name is Rajesh Chundury. I go by Raj. I am responsible for customer solutions in the broadband access business unit at Radisys. And today we're going to talk about our newest announcement on open and disaggregated solutions for broadband access called Connect Open Broadband. And I want to talk a little bit about how the architecture is laid out. And then I want to talk about how some of the deployment options used in this architecture are possible. In this picture, as you see here, you have your traditional way of building networks in the blue. And then, of course, you have your open and disaggregated way of building the networks on your right. If I were to take a PNF, a physical network function as we know today, and if we do the hardware software disaggregation to start with, the picture on the right that you see here with the dotted red box is the software-defined PON. It is effectively the PON control and management layer that has been disaggregated from the OLT and has been rebuilt completely cloud native and using containerized network functions with Kubernetes to manage these microservices. The software itself, SD-PON software, has about 4 key layers. One is the open OLT adapter from the ONF SEBA project, then the ONF open source Volta, and of course, ONF open source ONOS controller that essentially treats the underlying PON network as a programmable switch. We're taking those 3 layers from open source ONF, and we are using, we're wrapping them around with our some microservices from Radisys that effectively are doing control and management applications for you to enable to manage and run the software as a cloud native application, whether it is run on a telco cloud or on a public cloud. And it manages the white box OLTs on the bottom using the open OLT interface, which is again defined by the community, for the community, in the community. The community reference being the SEBA Volta at ONF.
Okay.
Jim, as you see in this picture here, the one in the middle is the current way of working, right? I mean, most network operators today have a couple of vendors, and it is a full stack, obviously. The software, the hardware, and the management system all come from vendor A or vendor B. And there are some advantages to building those networks the way they have been built today, till to date. But with the growth in the traffic that is happening, and the way to build these networks where the control has to be brought back to the network operators. Like we talked about earlier, disaggregation is key. And once you disaggregate, the question now becomes how and where do you run this disaggregated software? In essence, there are 2 options. On my left are, on the screen as you see, option A, which is called the distributed control plane. And on the right, the option B, which is called the centralized control plane. So let's talk about the centralized control plane first, because that is the most natural way of evolution for a disaggregated solution. So once you take the software out of the OLT itself, and as I've shown you earlier, it is made up of open source components primarily, but now it is commercially hardened, it is scalable, it is secure, and it can obviously now be deployed in an NFVI infrastructure in the cloud. It manages the OLTs over the open OLT interface. And the common management framework effectively allows you to manage this one SD-PON instance that can now control not just one OLT, up to maybe 100 OLTs, depending upon what the network configuration might be for any particular network operator.
And this is agnostic to the underlying type of PON technology?
Absolutely agnostic to the underlying PON technology, because the Volta layer that we saw, which is essentially the PON control plane, is the one that depicts or that implements GPON, XGS-PON, NG-PON2, or for that matter, next-gen PON, whether it is 25 gig or 50 gig PON. So
okay. You got it.
The control plane deployment, the centralized control plane deployments on the right, which are essentially high density deployments. If you take the case of Mexico City, Los Angeles, or Mumbai, where they're very dense cities and the population are living pretty close to each other, a deployment like that makes a lot of sense, because you now have visibility across, like I said, over 100 OLTs, and any control plane decisions that you take can be pushed within full knowledge of all of the subscribers and all of the OLTs within that large city. On the left side, the distributed control plane, option A, is sometimes more amenable for low density deployments. You're talking about the rural deployments, whether it is in India or in Africa, or Latin America, or even right here in the US. We have a lot of municipalities and rural networks that are spread far and about. In those scenarios, we take the option A, where you actually run the disaggregated software back on the OLT. But the key difference here is that the disaggregated software is open source and still manages the underlying white box OLT using the same open OLT interface that you see on the centralized control plane. So the software, SD-PON software, whether it is running on an x86 execution environment, on a OLT, or on a telco cloud, is the exact same software. But the scale with which it operates is obviously much smaller when you do a distributed control plane. This allows for low density deployments, Jim.
Are the benefits that you're looking for here primarily about the management and the control plane of these PONs, or do you have something bigger in mind?
Yes, obviously, to start with, disaggregation itself is a big step, and we expect that it's going to be a phased approach where you disaggregate the software. You probably go to a distributed control plane to keep the network operations just the way they are. And once the operations folks are more attuned to the IT technologies and the IT folks are more attuned to the network technologies, we see a move towards centralized control plane only if needed and where it makes sense. In terms of what's coming in the future, as you can see, if I may go to the next slide here and walk you through a vision of what might be possible. You can start with the distributed control plane. We see where as you mature and you are ready to do centralized control plane deployments, you can rehome the OLTs into a centralized control plane. And now the question is, what do we do with the compute power that has been sitting in these OLTs? And could they do more things than they are currently doing? And here, Jem, is where we want to talk about the possibilities of the art of what is possible, if I may, right? As you can see here, on OLT1, you can start to take the BNG, you can disaggregate it, put the control plane right next to the data plane in the OLT, and put the BNG control plane near the SD-PON control containerized network function in the NFVI layer. Now, you can do a couple of more things that is more visionary in sense, right? You could now run a CDN application on the OLT, assuming that you have the right hardware horsepower inside the OLT. And then if I take the example of a 5G millimeter wave small cell, where the RU, CU, DU are integrated as an integrated 5G small cell that is serving the same homes that the wireline provider is serving there, you could very easily backhaul the traffic over an XGS-PON 10 gig up, 10 gig down connection, drop in a 5G UPF function, have the local breakout of all the traffic that needs to be sent out to the internet, and write off and hand it right off, so you can save a lot of capex and opex and transport costs for 5G millimeter wave small cells as well.
Hey, Raj, thanks for taking the time today. Really interesting stuff. I hope to learn more.
Oh, no, thank you, Jim. It was wonderful to spend time with you today. And as you have seen, we have a very exciting and innovative proposition for fiber network providers, service providers, and we hope to be able to talk to more of our customers with what the open ecosystem can do.